Algebra 5-3, Notes 3, Interpret box plots. Identifying outliers. An outlier is defined to be any data value that is more than 1.5 times the interquartile range away from the nearest quartile. So what we need to do is find the interquartile range and then multiply it by 1.5. Then we need to take that product and subtract it from our first quartile and also add it to our third quartile. So I'm going to skip A. I want you to do that on your own. Let's look at letter B. The numbers of games won by 10 chess players are 5, 3, 6, 17, 2, 16, 3, 8, 6, and 4. Identify any outliers and create the box plot. The first thing you need to do is to put the numbers in order from least to greatest. So go ahead and do that right now. Okay, so here are the numbers listed in numerical order. 2, 3, 3, 4, 5, 6, 6, 8, 16, and 17. Now when constructing box plots, we need to find our 5-number summary. We need our minimum and our maximum. So the minimum here is 2. And the maximum is 17. To find the median, I need to find the middle number. Well, there are 10 numbers, so it's going to be between the 5th and 6th digit, which is right here. Between 5 and 6 is 5.5, which is our median. To find our first quartile, I need to find the center of these 5 digits on the left, which happens to be this 3. So this is quartile 1. And same on the other side, the middle of these 5 digits is 8, which is our quartile 3. Before I graph it, I need to find the outliers. So the first thing I'm going to do is find the interquartile range. The interquartile range is always the third quartile subtracted by the first quartile. So to find IQR, we have 8 minus 3, which is 5. So the interquartile range is 5. Now to determine if there are any outliers, what we need to do is take that interquartile range and multiply it by 1.5. When we do that, we get 7.5. Take this product, subtract it from quartile 1, so 3 minus 7.5 gives us negative 4.5. And then we need to take that number 7.5 and add it to the third quartile. So our third quartile plus 7.5, and we get 15.5. So we now have a range from negative 4.5 all the way to 15.5. Any values that are outside of that range are considered outliers. So in other words, we're looking for values smaller than negative 4.5 and larger than 15.5. If we look at our data are all positive numbers, so we have no outliers on the lower end. Our upper range here is 15.5, and we actually have two numbers that are greater than 15.5. We have 16 and 17. Those are considered our outliers. So identify any outliers. Outliers equals 16 and 17. Okay, and then we need to create the box plot. When we're creating a box plot with outliers, we actually identify the outliers by putting a little asterisk or dot where those numbers are. So I'm zoomed in on my graph here. My outliers were at 16 and 17. So I'm going to put a little asterisk on 16 and on 17. Those are the outliers. The next largest number we have is 8 in our list. Well, 8 is also our quartile 3. So let's draw a vertical line at 8. We need a vertical line at 5.5, which is our median. We need a vertical line at 3, which is quartile 1, and a vertical line at 2, which is our minimum. Now, normally on box plots, we have two whiskers, and we have the interquartile range, which is the box. In this case, we happen to only have the box and one of the whiskers. The reason being, our outliers are the highest two numbers in the data, and the next highest digit is also, which is 8, is also quartile 3. So we actually cannot extend a whisker. So let me finish this up by putting a title. I'll label it Chess Games 1. And from here you can go back and do letter A. Interpreting box plots. Determine whether each statement is true or false. So we're going to use the box plot on the right here. Before I look at any of these, I want to figure out what these numbers are. So we have, right here's a minimum, and not all box plots have the whisker vertical lines, but it's the same thing. So here's our minimum, which looks like it's at 0. So I'm just going to jot that digit down. Right here, it looks like it counts by 2, so in the middle would be 1. So our quartile 1 is 1. Quartile 2, or the median, is 2. And our quartile 3 looks like it's in the middle, so we'll say 5. And we have our maximum at 10. Actually, our maximum is this outlier here at 12, but this stops at 10, and this value is 12. So let's jot those down. Now let's go ahead and look at these statements and figure out if they're true or false. 5 is the median of number of pets. Our median is where this middle bar is, which is 2, so this is false. 50% of the people have between 0 and 2 pets. Remember, each quartile is 25%. So this is 25%, and from here to here is 25%. So from 0 to 2, there is 50% of the data. So yes, that is true. The IQR is 4. To find the interquartile range, we subtract our quartile 3 minus quartile 1. So 5 minus 1 is 4. Yes, the interquartile range is 4. That is true. 75% of the data have at least 2 pets. Well, 2 pets is the median, which means this is 25%, and this is 25%, which makes 50, not 75. So this is false. 12 people were surveyed. There is no way we can determine from a box and whisker plot how many people were surveyed, so this is false. The variance from the minimum to quartile 1 is the same as the variance from quartile 1 to the median. Well, the variance from the minimum to quartile 1 is from 0 to 1, so the variance is 1 there. And the variance from quartile 1 to the median from 1 to 2 is also 1, so that is true. Most people have between 5 and 10 pets. Well, between 5 and 10 pets is not even 25% of the data, so that is false. 12 is an outlier. 12 is represented by an asterisk, so that is true. The box and whisker plot below shows the distribution of sneaker sizes sold at Pete's Feet Store one evening on January 12th. So let's take a look here. We'll start with this question on the top right. What is the median? Well, the median is represented by 7. What percent of people bought sneakers a size 6 or smaller? So we are looking at this section right here, which is a fourth of the data, which would be 25%. Jumping left to this question. What is the shape of the distribution? Well, the tail end is on the right-hand side, so we would say this is skewed right. Which value represents the 75th percentile? Well, here's the 25th percentile, 50th, 75th, so that value would be 10. What percent of people bought sneakers between size 6 and 10? Well, between sizes 6 and 10 are two sections, which would be 50%, two quartiles, I should say. Between which two statistics is there the least variance? So we're looking for the smallest amount from one quartile to the next, which is represented here between 6 and 7. Suppose 20 people bought sneakers on that day. How many of them bought sneakers greater than size 10? Well, we need to know what percentage is greater than size 10. Greater than size 10 is this quartile, which is one quartile, which is 25%. So we are essentially finding what 25% of 20 is. To figure that out, we just change our percent to a decimal, so 0.25, and then multiply it by 20, which is the total amount of people, and we get 5. So 5 people bought sneakers greater than a size 10 out of the 20. Go ahead and do letter C on your own. Letter D. The box plots below show the delay times for big air flights in December and in January. So what I like to do before I answer any questions is figure out where all my quartiles lie. So if I look at the December delay times, we've got 0 as our minimum. It looks like we count by 20s on our number line, so that would be 10. I would guess that this is close to 15. Our median looks like it's right in between, so I would say that's 30. Our quartile 3 is definitely 60, and our maximum is 120. Let's look at our January delay times. Again, we have 0, 15, 30, 50, and looks like it's about 100. I'm sorry, 95. It's between 90 and 100, which would be 95. All right, so let's take a look at the questions here. The median is a good measure for a typical delay time. Compare the medians of the 2 months. Well, the median in December is 30, and the median in January is also 30, so we can say that the medians are the same. The range and IQR are good measures of variance. Find the range and IQR for each month. Use this information to write a statement comparing their variabilities. So the range is your largest value minus your lowest value, subtracted by your lowest value. So your largest value for December, let's do December first. We're doing our range. The largest value we had was 120, and the smallest value we had was 0. Subtract those, and we get 120 as the range. With the interquartile range, again, we're looking for the third quartile subtracted by the first quartile. Our third quartile is 60, subtracted by 15, which is our first quartile, which is 45. Now, January, the range, our largest value in January is 95. Our minimum value is 0, so the range is 95. And the interquartile range, third quartile is 50, first quartile is 15, subtract and get 35. So then we need to write a statement comparing their variabilities. Well, the range is 120 versus 95, and their interquartile range is 45 versus 35, which are a little closer. So we've got in red here December, which tells us, and these numbers here are larger than the numbers in January, so that tells me that December's delay times were more varied than January's delay times, meaning they were more spread out. So let's go ahead and jot that down. So over here on the right, December's delay times were more varied than January's delay times. If you were planning on flying Big Air, would you rather book a flight in December or in January? Well, if December has longer delay times and is more varied on their delay times, I would much rather fly in in January, because they're more consistent with their delay times. So let's put that down into some words. So January, because flights are likely to be delayed longer in December than in January. And go ahead and finish letter E, which is comparing 4 different box plots.